Hello everyone, welcome back to this channel. Till now on this channel we have solved the array problems using prefix sums, hashing and two pointers. Now we are going to start with a new pattern, sliding window pattern. Sliding window is not a new algorithm, but it is a way of reusing the work instead of recalculating or recomputing it. So now we are starting with the simplest form of this pattern. But before that I would like to explain that why the sliding window exists. So whenever the problems ask about the subarrays, we are calculating repeatedly for something for the overlapping ranges, and this is where the sliding window helps. Means we need not to calculate the things repeatedly for the overlapping ranges, but we have to just move our window. We have to just maintain a window so that we can slide that accordingly whenever it matters, whenever the changes happens. So this is where the sliding window helps. Here also I have just mentioned that we have to use the sliding window for avoiding the recomputing of the subarrays. So whenever there is a subarray in a problem, and also we have to calculate something repeatedly for the some of the overlapping ranges, then this is where the sliding window helps. Now let's just take a simple problem based on this particular pattern and understand how the sliding window helps. So this is the problem statement which I have taken. This is based on the sliding window, and also more specific, it is based on the fixed window sliding window problem. So this is the problem, the maximum points which we can obtain from the cards. The problem statement is that we are given with an integer array card points of length n, and here each of the element represents the points on the card, and we are also given an integer k. We can just pick exactly k cards, but there is one rule here that we have to pick the cards from the begin or from the end of the array, and each card can be picked at most once, and the task of this particular problem is to return to the maximum total points which we can obtain by picking exactly k cards following the above rules. So let me just explain this in short, that we are given with an integer array card points, and there are like each element in this represent the points on the card. Now there is one integer k. What is this integer k? The k is the number of cards which we have to pick from this array, and those exactly k cards which we have to pick, that is based on one rule, that is based on one restriction, that whenever we pick the cards, that those cards can be picked either from the beginning or from the end. It means from the front or from the back. So those key cards which we have to pick, and we have to pick those cards in such a way that it can give us the maximum total points, and that particular maximum score we have to return. So this is all about this problem statement. But first, the one confusion can arise in your mind that okay, in this problem is saying that we have to pick these cards from the either ends, from the beginning or from the end. So how this problem is related to the sliding window problem? See, first of all, this confusion can come, and it is very normal. But if we observe something here, then we can come to know that okay, exactly k cards we have to pick, and after picking these k cards, what are the cards left in the array? Those are n minus k cards. Total n is the size of this array, and k cards which we are picking for the maximum total, n minus k cards are left. So if these k cards are giving us the maximum total or the maximum score, then those n minus k cards on summing up can give us the minimum sum. So now the problem is not about directly picking the key cards. Now the problem, we can convert it into another problem, that is a simple problem, in order to get a particular subarray which is of length n minus k, which can give us the minimum sum. So now instead of picking the key cards directly, now we can restate this particular problem, that find a contiguous array which is of length n minus k, which can give us the minimum sum. So that is the problem now we are going to solve, and whenever we can come up with such a subarray with the minimum sum, we can just take the difference of the total sum of this subarray and of that subarray which is having the minimum sum. That can give us the maximum score or the maximum total, which will be the maximum total which can come up after this picking the key cards. So this is the problem statement. Now here I have taken one example of this array in which the array is of size 7, and we are given with a value k equal to 3. It means we have to pick exactly 3 cards from this input array. Means these every element in this is representing a point. This 1 2 3, these are representing the points on the cards. So 3 cards which we have to pick exactly, we will not be picking directly the 3 cards, but we will, what is the problem which we have restated, that we have to find a contiguous subarray of length n minus k, which is giving us the minimum sum. And when we come up with such a subarray, we can just take the difference of the total sum and the minimum sum subarray. That can give us the maximum total or the maximum score. So this is the problem all about. Now one more observation which we can make from here, that we know that whatever the window will be formed, that will be formed of n minus k length. It means the size of the window is not going to change. It means this is the fixed window sliding window problem. Okay, so this is one thing which I have to mention here. Now let's just perform a dry run on this problem, and then we will come to the code part, or the implementation part. So what we have to firstly do is, means how we have to maintain this window. First of all, we have to pick n minus k cards, or we can say n minus k elements from the start, and then we will go step by step that how we have to maintain this window, how we have to slide this window. So first of all, let's just maintain the n minus k elements at the start. So what will be the n minus k elements? Let's just see here. What we know is that n value is 7 in this case, and what is the value of k? K value is 3 in this case. So what will be n minus k? That will be 7 minus 3, that is 4. So we will have to maintain the 4 length window. What will be the 4 length window? That will be from 0 to 3, third index. Okay, so now what is the value of n minus k? That is n minus k is 4. So it means we have to maintain the window of n minus k length, that is 4 length. So what will be the 4 length window from 0 to third index? So this will be the window. Let me just mark it here. So this is the window from 0 index to the third index, means of 4 elements. Now let me just change the color of this. So, okay, this is the window, and now we are having this window at the start. So what we can just do is, we can just take the sum of this window, whatever the points are present inside this window. So what will be the sum? So let's just keep that sum as that variable as sum, and that will be 1 plus 2 plus 3 plus 4, that will be 10. Okay, so now we can see here that the sum in this, inside this particular window, whatever the cards are present in this window, that sum is 10 till now. So now whenever we will move this particular window ahead, what the things changes? First of all, the leftmost element will be going out of this window, and the rightmost element will be coming in inside this window. So first of all, the sum, how the sum changes. Let's just take this sum inside the another sum, that is the minimum sum, let's see. So this is the minimum sum. This is the minimum sum, and now in this we will be updating the minimum sum. So when this window moves ahead, this leftmost element leaves this window and the rightmost element enters inside this window. So this 1 will be subtracted and this 5 will be added. So what will be the, what will the sum become? The sum will become 10 minus 9, 10 minus 1, that is 9, plus 5, that will be 14. So now the sum becomes 14. And what is the minimum out of 10 and 14? That is 10 itself. So inside this, uh, this particular sum will become 14. And now what is the minimum out of 10 and 14? That is 10. So 10 will come inside the minimum sum. Now we can see that this window moves ahead. This is the window right now, and for this the sum is 14. Okay, you can also recheck it from here, that what is the sum of this. So 3 plus 2, 5, 5, 10, and this 14. Now again, this particular 2 will leave this window and this 6 will enter inside this window. So what will be the sum now? The sum will now become 14 minus 2, that is 12, plus 6, that is 18. So now the sum becomes 18. And now what is the minimum out of 18 and 10? That is 10 itself. So the minimum sum will have 10 in that. Now this window moves ahead. Okay, now this window moves ahead, so it is now from second to fifth index. Now again, when this window moves ahead, this 3 will move out of the window and 1 will enter inside this window. So what will the new sum becomes? That is 18 minus 3, that is 15, and plus 1, that is 16. Okay, so this sum will now become 16. And now what is the minimum out of this minimum, this 10 and 16? That is 10 itself. So now the minimum sum is having inside it 10. So now this window moves ahead. So you can also recheck it from here. The 6 plus 4, 10, and this 16. So the sum is 16, but minimum till now is 10 itself. So this particular window will be maintained in such a way that the left and the right pointers will be the boundaries, and the right pointer, when it comes at the n-1 index, means at the last index. After that, we need not to check, because now if we are trying to slide this window ahead, then there are no any indexes of this particular array, and that will give us the error. So till the point this right pointer is not at the n-1 index, till that point only we have to maintain this window. Okay, and after that we have to just stop here. So this is how we will get the minimum sum at the end, means 10. And now whenever this particular sum we got, we just take the total sum of this entire array, whatever the total sum will be there. the difference of the total sum and this minimum sum will give us the maximum score, because initially the problem has asked us to get the maximum score or the maximum total by picking the k cards, exactly k cards. And we have done opposite, that we have took a subarray n minus k, which is giving us the minimum sum, so that whatever the left cards are there, means the cards which were remaining, those are the k cards which we have to pick, which can give us the maximum score or the maximum total. So that is how we have solved the problem. So this is the sliding window problem, and in which the window is of the fixed size, so we can call it as the fixed window sliding window problem. So this is the problem all about. How we got this minimum sum is 10. This minimum sum 10 we got from these particular cards from 0 to 3rd index. And this is why we can say that these cards from 4th, 5th and 6th index we must pick, so that we can get the maximum score or the maximum total. Okay, means obviously the problem has told us to pick the cards from the either ends. So first we pick from the last from the end, from means the one, and for the next iteration we have picked again the next card from the end, that is 6, and for the next another iteration we have again picked one card from the end, that is 5. So this is how these three cards, exactly three cards, are giving us the maximum total or the maximum score. This is how the minimum sum we got from this particular cards. And now if we take the total sum, what is the total sum here? Let's just check that. So total sum is 1 2 3 3 6 4 10 5 15 and this 21 and this 22. So total sum is 22. And what is the minimum sum we got? The minimum sum we got is 10. And now when we take the difference of both, so we can get the maximum score will be 22 minus 10, and that will be 12. Now let's just come to the implementation part, and let's see how we can implement this particular thing in code. So we have to complete this function. First of all, let me just take the size of this card points array. So this is the size, card points dot size we have taken inside n. And now I'm taking 2 pointers. One is the left pointer and the right pointer for the boundaries of this particular window. So left pointer will be pointing at the 0th index, and the right pointer will be pointing at a particular index. See, we have to firstly maintain a particular window which will be pointing which will be having the 4 elements at the n minus k elements at the start. So if the n minus k elements are there, then the indexes will be from 0 to n minus k minus 1. See, means n minus k is 4 here, so this is going from 0 to 3, and n minus k is 4, so it means from 0 to n minus k minus 1. So right pointer will be pointing at n minus k minus 1, n minus k minus 1, where the right pointer will be pointing. Now first of all we have to take the sum of this particular elements or the card points in this particular window. So for that I will have to just maintain a window sum. Okay, let me call this window sum equal to 0 right now, and also I have to take this sum here. So let me also mark them as left and right here. So left and right pointers are pointing here. Now I cannot take this left pointer into consideration in order to take the sum of this entire points inside this particular window, because if I am doing so, then the left pointer will move till this particular index, and after that I will not be able to make the modifications of the left and the right pointers accordingly to move this particular window. So I will just take this left pointer inside the another variable. I will just call it as I. So int I equal to left. Now this I is pointing at this left pointer, okay, in order to keep this left pointer intact. So now I will take the sum of this elements inside this window. So for that I will just run a loop here, and inside this particular loop will run until this I is less than equal to right. Okay. And till that point I can just take the sum. So this window sum which I am maintaining here, this will be equal to card points of I, and every time I will be just incrementing this I after taking the value inside the window sum. So this is how I can get the window sum. So what the window sum I got here, the window sum is 10 in this case. So let me just write here, this window sum is 10 in this case after completing this entire while loop. And now this I is pointing here. Okay, so now the work of I is completed, and now let's just come to the main logic where the window will be moving. So now the window sum is 10, and for the next time I will just take this window sum inside the minimum window sum which I have to return. Okay, this is the minimum window sum, that is the 10 I have taken inside this. Now whatever the changes will be done, that will be done inside the window sum, and every time I will just compare with the minimum window sum. Whatever the value will be minimum, that will be coming inside the minimum window sum. So now for the another time, I have to just take the minimum window sum, that is int minimum window sum. What the value I will be taking inside this, that will be the window sum. Okay, so this value I have taken as I have just mentioned here, and now I will just run another loop that will be for right not equal to n minus 1. Okay, that I have already told when we are performing the dry run, that whenever the right pointer comes at this n minus 1 index, after that I cannot slide the window. So till the moment this right pointer is at this not at the n minus 1 index, till that point only I can slide the window, so that any error should not occur. Okay. So now what we have to do here is we have to just take this window sum, whatever the value is there inside the window sum. We have to take this window sum, and in order to slide the window, what I will be doing, I will just take this leftmost value, and I will remove it from this window sum. And after removing only, I can I can take this left pointer ahead. What I have to do here, I have to just subtract it. Okay, this is the card points. How I can take the value? This is the card points of left, and after doing so I will just move this left pointer ahead, and also I have to add the value from the right. So first of all I will move this right pointer ahead, and then I will add this value. So again I will be taking this value from card points. See, card points, and first of all what I told, that we have to move this right pointer ahead, then only we will be taking the value inside this sum. So this is how we can get the value inside this. So what how this window is moving ahead? First of all, this left pointer value is removed from this particular sum from this window, and then the left pointer is moving ahead. And the same in the case of this right pointer, where the right pointer value, first of all the right pointer will be moving ahead, and then only the value will be added inside this window. So this is how the window is sliding. And for the next time we will be doing the same thing. And also whatever the minimum window sum we are maintaining, that this is the minimum window sum, every time we have to just compare it with the minimum window sum, and whatever the value will be there, that will be updated. So with the minimum window sum, and the current window sum, whatever the value will be minimum, that will be coming inside the minimum window sum. And at the end, whatever the value will be there in the minimum window sum, that will be the minimum possible value from a particular contiguous subarray, which is giving us the minimum sum. And at the end, what we have to return, we have to return the difference. What difference? The total sum and the minimum window sum, the difference of these both, which can give us the maximum score. So in order to get the total sum, first of all I will just take the total sum variable here, total sum, that is equal to 0, and I will just run a loop for auto val, and from this card points array, I will just take this total sum, every value inside the total sum, and add in it. Total sum equal to total sum plus value. This is how we can get the total sum. And also there can be one edge case. Okay, that edge case will be what? There will be one edge case. That edge case can be that whatever that, if the k value is given equal to the size, means whatever whatever the size of array is. So if that k and n both are equal, it means we have to pick all the cards which are present inside the array. So in that case, the answer will be the total sum. So we can just keep a condition here, that if this k is equal to n, then in that case I can just return the total sum. Okay. This is the total sum, which will be the maximum score or the maximum total in that case. Otherwise we have to just come here, and we have to take the difference of this total sum minus the minimum window, minus the minimum window sum. This particular difference will be the maximum score or the maximum total. So let's just run this particular code. Okay, what's the problem? Okay, window sum. Let's perform a run here. Okay, this is with this. Okay, so we have seen this particular problem with the logic and along with its implementation. Now let's just see the time complexity and the space complexity. So here we can see that whenever a particular window is sliding or it is moving, we can see that every element is leaving this particular window once and also entering inside the window once. So therefore this particular algorithm runs in a linear time. So the time complexity, overall time complexity of this algorithm, of this solution, is O of n. And if we talk about the space complexity, so space complexity is constant, that we are not using any of the space in this particular problem. So this was a problem about the fixed window sliding window problem, which is a foundational problem in order to understand how the sliding window works. And now in the next video, we will come up with a problem based on the variable size sliding window. Okay, and that will become more interesting. So till then, just keep learning, keep growing. And this is Aditya Pataria signing off. Thank you.